Welcome to the AWS for AI podcast.
Welcome to AWS for AI, the podcast where we explore cutting-edge AI solutions and the innovators behind them. I'm your host, Hamza Mimi, AWS Solution Architect, and I'm happy to welcome with us today Moayad Rayan, a partner and head of technology at Virtue. Virtue is a research and innovation center of Ownverse, founded in Dubai in 2021, and dedicated to bridging the gap between humans and machines. Moayad has a long software development background, managing real-time systems with hundreds of millions of requests a day, but today he will take us to a whole new dimension of emotional AI that I personally did not think AI was capable of before. Virtue provides the tools to genuinely understand, interpret, and respond to human emotions based on psychological understanding, creating more natural and empathetic experiences. Based on theory of mind in psychology and proprietary emotional data analysis and automation model, Virtue are able to measure, model, and predict human emotions and the human emotional state at any given moment. Moayad, it's a pleasure to have you with us today. Welcome to the show.
Thank you so much. Likewise.
Before I start, and there is a lot to unpack here, I want to discuss your personal story, how you moved from this massive background in software development to where you are today as the head of technology for Virtue.
Of course. Let me go on to the beginning. I'm a Jordanian, a father of 2 kids, and married to a wonderful wife. She was able to resist all the stress I put on her because I decided to do what I'm doing now. I've studied software engineering, and I was always fascinated with the science fiction movies. Even when I'm young, I used to watch these movies a lot. And I got always that feeling that I would like to join this kind of development or this kind of a revolution where technology comes to help the humans and do kind of science fiction stuff, but it became into a reality because there is a science behind that. So my story with Virtue started 5 years ago when I met the co-founders, Mark and Elizabeth. They started to explain to me what is the science they are developing outside of technology. That's really attracted me very much because what they were telling me is completely a kind of science fiction, but it can be applied to become true technology that really helps the humanity, and it becomes a very complete, useful tools for everyone who would like to take advantage of that tools, of course. Where the main idea was empowering the technology or let's say to keep the technology sensitive enough to understand the human emotions that will produce helping the humans to always remain authentic and improve their capabilities of doing things by understanding their emotions and their states at that moment on real time.
Yeah, very fascinating things, and I'm catching myself trying not to go in depth before we understand the general picture, because we'll have a lot of time to discuss all the psychology, theory, and research that has been done in this field. Maybe can you talk a bit about Virtue as a company? What's the mission, how it was created, and what's the things that you are trying to do with Virtue today?
Yeah, of course. Well, the mission is always used to be the same since day one, where we are creating the path where technology empowers human authenticity. And what I mean here is, instead of all of us to be like a robotics or following a specific program, where we empower the technology to have the human sense, which is the emotions and the psychology understanding, where it delivers, or at the end, it encourages us to stay the unique selves as humans, not just following a program.
So, how is Virtue trying to achieve that? What's the long-term goal for the company as a whole?
All right, we are trying to achieve that by creating our science-based foundational model, and actually, we have the whole story started when the co-founders spent around 8 years in research and in psychology research, where they have developed and found the right theories that or science can be extracted from the psychology understanding of the human being, and that can be transformed into the technology by empowering the technology with that kind of science, where now the technology became sensitive enough to understand human emotions, which will impact at the end delivering a very customized content or experience fit with the human who's interacting with the technology, rather than just cold machines. It just respond to any requests randomly without understanding the human state behind the screens.
So you initially you joined in the technology era of Virtue, and the founders were working for 8 years building that foundational knowledge and science in order to get it to a maturity level where it meets with AI and technology, and to get to the point where you are able today to build all the fascinating products that we will talk about, right?
Yeah, exactly. That's the
Interesting.
case.
So I want to just go ahead and tackle some of the practical use cases and the things that you are working on right now. Can you talk a bit about what are some of the use cases in general that Virtue are handling, and what are some of your customers?
Of course. Let me tell you about what we are working on, and then I can tell you approved use cases where we have implemented our technology and we found it very useful. First of all, now we are working on launching our production platform, which is Orchestra, which works, or let's say which will be a tool given to all the AI companies who's building any human-centric solutions, and that tool can be used to add the human senses to their technology or their solution or their application. So some of these use cases, first of all, our foundational model is completely based on a science based. We don't use a data sets or pre-trained patterns to predict, and we are always working proactive, not reactive. We don't wait until the things happen to understand why it happens, and then we act, and that's how exactly one of unique capabilities that we have. So talking about use cases, we have a solution, we call it HERS, which stands for Human Error Reduction System. This system works as assistant to a safety operators while they are driving a vehicle, for example. So this system keeps understanding, or let's say keep monitoring the human state who's operating the vehicle, and finding wherever there is a stress or a distraction happened during that operation, and we notify, or let's say we remind that operator to come back to his focus, to his attention, because he's driving something can harm other people or can harm himself. Yeah. So this is exactly what we have applied on HERS, and I can share with you an example where back in 2022, there's an article published publicly of a newspaper where we partnered with another company, and we have positioned our system in RTA. While the operator's driving, our system was always analyzing the human state, and that gives two signals. If there is any distraction happened, we directly remind the operator to come back to his focus level, to his attention, because he's supposed to always keep focusing what he do, because he's driving a vehicle, and it's kind of might make an incident which is and injuries may happen. And in another hand, this same system can notify back the operation room about the state of that human, because sometimes he got tired, he's not able to continue. So we notify the operation room that this driver, he reached the limit. You guys have to give him a rest, replace him with someone fresh that he can continue driving.
Oh.
So let me just quickly give you a quick story happened while we are testing and validating the system. There was one operator who was, I think the day before he came to work, he had a kind of argument or a problem with his friend. So while he was driving, he was just thinking he should go for a revenge or just forgive that friend. And at that moment, while he's just thinking about the possibilities, our system directly notified the drivers. Are you okay? At that moment, the driver realizes that he should come back to his focus into what he's doing, and later he can think about these things. And this is how we validated our system in a real case.
Brilliant. Just for people that that are listening to us, RTA is the Dubai Road and Transport Authority, right?
Yes.
I want to maybe go. All of the work you're doing is grounded in the theory of mind. Maybe let's go a bit deeper into what's the theory of mind and where we can understand this work that have been done by Virtue and by the founders and from the science perspective, and then go back to some other use cases. Can you explain maybe in simple words for somebody who's never heard about theory of mind, what's that?
All right, the theory of mind is a science, exists in psychology, and it's very long story if you would like to discuss all about theory of mind. But what I can basically explain it as every person or all people has their intention, feelings, or reasons for doing things, and from there we would understand that why that person did that kind of action. Giving you an example on that, maybe to just simplify the idea, considering that there is a person goes to the kitchen and opens the refrigerator, and he starts looking inside the refrigerator. If you look at that person, you will be easily able to understand that either he's looking to eat something, he's hungry, or he just want to eat. That's exactly the theory of mind. Unintentionally, you can understand people's why they have intentions to do things.
So when we're born, we don't have that theory of mind and understanding of how people are actually thinking, and we start learning that as we grow older. And basically, to my understanding, and correct me if I'm wrong, is theory of mind is how you understand how people think, right?
It's how you understand why they are doing what they are doing.
Exactly.
It's the reasons behind that.
Okay.
And this is our system. We are trying to understand the reasons behind that to proactively take actions or personalized actions.
So if somebody is putting a jacket, having that theory of mind basically allows you to understand that at some point maybe he's feeling cold, and you internalize that and think about how basically we are social humans, social beings, and by understanding why people behave the way they behave, we basically adapt and adjust.
Yeah, exactly. Okay. That's the concept behind the theory of mind.
Interesting. And now bringing that, which humans developed over, I guess, their evolutionary history, to AI, what you're trying to do is basically to make AI aware of why people behave the way they behave. Is that a correct?
Let's call it sensitive enough to understand the human emotions and give extra advantage instead of just following a program or just application program to execute this way. No, we fit the context, or let's say we interpret the real-time inputs and human emotions to be able to proactively decide, not a programmed or a program that's always followed as is.
Yeah. So based on this understanding of the theory of mind, obviously developed the emotional data analysis and automation system. That's your proprietary platform. How can you get from that theory to the EDA you developed, and what's that exactly doing?
All right, our EDA, we call it
Yeah.
EDA, which stands for Emotional Data Analysis and Automation. It is our main foundational model. It's combined from about 12 core models, and these models are works in real time. Now, there is 8 of these models are work sequentially in real time. The moment we receive an interaction, we call it interaction, whenever someone interacted with our system, we go over these 8 models in real time, and these models are totally to understand the human state, and at the end generates a personalized action as a response to that interaction.
So what does this model or mixture of model in reality take as an input, and how do you modelize that?
All right, the inputs can be a variety of psychological, environmental, and behavioral. These 3 combination of inputs, we added part of the interaction, and from that perspective, we will start analyzing. It goes over the science behind those models, and we understand, or let's say we extract what to be personalized and what the action should be responded to that situation.
So from a science perspective, you're having an approach which is different than using large amounts of data to predict something. You're actually basing your models on actual science. So how do you use that science to encode it into the model? So you're using live data. You're doing some kind of modelization of the inputs coming from the environment and the person that you're modelizing?
All right. We don't have a data sets to train our model. We haven't started, or the initial state of our model, foundation model, is not being trained over data sets. We don't have data. We don't manipulate that data even. As we completely built all these models completely based on a psychological science, that each part of this model specialized in a specific area of the psychology of the human, and at the end we combine the overall outcome, and we decide what to respond, or let's say either decide what to respond.
So you have different layers of specialized models,
Yes,
that you combine into a larger solution, and basically you are able to route depending on the things you're trying to do to the right model, right?
Yeah, exactly. Because at the end, when we talk about emotions is something. Emotions something cannot be labeled, categorized. You cannot identify. Let me tell you just a context here. Considering talking about love. Love is an emotion but taking deeper look, you love your mom, your wife, and your kids. All of them are called love. These emotions called love, but still there is a differences between these love, and that's what our model do. We are measuring the unmeasurable, but that truly matters. For example, this love example, when we talk about mother, it's because you respect, and when we talk about your wife, it's a partnership. Your kids, it's a matter of playing and caring them, and that's exactly our models, or the developed foundational model is to measure these differences depends on the or let's say it's tailored the context and the situation and the state.
So these mixture of model, you'll have a separation depending on the emotion you're trying to modelize, and you have different models like specialize in a specific emotion, or how?
Yes.
Okay.
Our human brain is very complex.
It is.
And even if we talk about the brain itself, it combines from a lot of parts. That's what we are trying to mimic. We are mimicking the human brains, combining all these components or core models together to come up with an similar to a human brain senses.
So this modelization, at the end of the day, you are able to modelize how human is thinking a specific time. And we discussed before basically the emotional states. Can you define what's an emotional state from your perspective, as per the how it's used and how it's defined in your modelization?
Well, this is a very deep technical question that's more into the psychology, and maybe I cannot add a very big value by explaining that. But what I can tell you is the inputs goes into this sequence of models, and every model extract the specific part which relates to that emotion, and at the end there is a final outcome which tell our foundational model what is the state, what's the context, what we are trying to personalize to be delivered in the end.
Okay. And depending on the evolution of the inputs, you're basically tracking the future mental states based on a certain metrics that you capture on different emotions.
It's on real time.
Okay.
That's the thing. It's not about the future. It's about the real time. Now, deeply, you can have different emotions like that, and I cannot see on your face, in your impressions. But you deeply, maybe you have distraction, you have a stress that I cannot see. But our system will be able to identify that kind of state because you are communicating with the system, either through analyzing your voice, your heartbeats, your EEG. Depends totally on what inputs you are providing to the system. And our system is completely customizable. It's not that if you would like to use our foundation model, you have to fit with this set of inputs. Whatever inputs, of course, we have a big set of inputs that you could use. Depends on your solution, your application. You provide the customized set of inputs you would like us to analyze, and based on that analysis, or let's say based on that selected inputs, we will be able to conduct our analysis on the real time.
And depending on the inputs, you'll then define the model itself will actually give you some of the actions that you can do in order to optimize the results of the situation that you're actually implementing.
Yes.
So you touched on that on the example with RTA. So basically, if you detect a risk based on your modelization of the current state, emotional state, then there is a high risk of a problem coming in, and then you will generate a notification, or depending on the context, basically. Where
of course, it depends on the context, but as an achievement, let me share with you some numbers. We have reduced 75% of the incidents during the trial period.
Oh,
yes,
interesting. So this means that most of the incidents were coming from actually the human state.
Always humans are committing to errors. And this is very normal of a human being. And that's what, if we talk about human error reduction system, that's exactly what we are trying to do, to prevent these errors from happening, to predict them in real time and notify that party, either the operator, the operation room, about what might happen based on the science.
This basically brings an additional layer of self-awareness to basically whatever you're doing, to get that external input that you need to actually make more attention to a specific area where you are thinking about that you didn't have before.
Yes, basically we are announcing that we are increasing the self-awareness.
This is brilliant.
Yes.
So beyond the increasing or augmenting humans, I can already see a lot of applications, and you're working on other applications as well. You touched on HERS. Can you dive a bit deeper about what kind of applications or use cases you're using from that?
All right. HERS is not only for automotives or vehicles or drivers. HERS is always about safety and being safe. So let's consider a very critical jobs or domains like oil and gas, safety, risk management. All these, there is a number of places where you can implement this technology, because at the end it takes the human. It's always human centered. So it analyzes and it predicts, and at the end, you as a client or as one who created that kind of experience or the solution itself, you decide how this technology should react on these certain contexts or situations.
So the goal first, just to restate, hers is for the error reduction.
A human error reduction system.
So human error reduction system, depending on the situation, oil and gas, you want to control risks for specific things that are happening from human errors, and you're basically able to detect that based on all external factors and by implementing the theory of mind and the psychological knowledge of the humans. I want to touch on the other use case from maybe experience simulation. So this can also be done to simulate a particular situation, and this is also some of the things that you were working on. Can you touch on some of the use cases and first maybe what's the experience simulation, and then some of the use cases?
Experience simulation is a solution where it utilizes EDA to create virtual humans. And when you say virtual humans, at the end is just to use virtual humans to validate specific concept or a specific place or a specific structure before it has been implemented. To put that humans or digital twins into that place, that environment, and see how that impacts in the evolution of the psychology of those users or those humans, let's say. So this experience simulation, it has a wide range of places where you can use it or benefits you can take. You can start take advantage of it. So one of these where we have validated our production version, one of these solutions, or let's say one of these implementations, there's an authority planning to build new concepts of cities that has not been implemented before. So if we don't have our technology in place, the case is they have to construct that city and see how it impacts negatively or positively into the humans who's living there, which is very expensive if you discover that this type of city impacts negatively. Taking advantage of EDA, our foundational model, science-based foundational model, we can create a virtual world simulating your city or your concept, your new establishment, building, whatever is that. And we can place the digital twins, the virtual humans, in that virtual world for a certain set of time. Let's say for a couple hours or couple months, just to simulate how a whole year, because in virtual world, time can be faster than the reality. And this is another advantage we can take about the virtual world. So if we let these virtual humans live for a month, which equals to 1 year, at the end, you will be able to understand how that new environment, during the simulation, we can apply multiple factors, environmental factors. Like we can change the light, we can change the materials of the surroundings. We can apply multiple weather conditions. At the end of that simulation, you will get AI insights about how what is the evolvement of this human from psychology perspective. For example, have we added more value to their creativity, or we killed their creativity and that has been reduced by the end of the simulation? Is just one sample of around 200 factors we can produce, like the anxiety, the creativity, and there are. It depends on what you would like to see on that simulation. We create the solution for you.
So you basically are able to modelize different human traits and different human entities on a virtual world where you just try to capture at the end certain metrics about does this environment we created increases anxiety or impacts creativity or all the emotional states at the end of the experience. And instead of doing that in real life, you're basically modelizing that, right?
Exactly.
Okay.
Where we reduce the risk of implementing something negatively impacts the psychology evolution of a human being. And you can take a lot of samples on that. It's not just building a city, maybe just building a new roller coaster in a Disneyland, or how you build a new university in a new concept that impacts positively on the delivering the learning to the students, or make it customized for every student so he can understand to the maximum as he can go.
Yeah.
Because not all humans are same.
So basically, you're bringing the social studies to the IT world and trying to, like, studies that takes years, you can now do in just accelerated mode, since we can accelerate, and have in 1 hour the results of 1 year of capturing the data from real world and just tweaking the input metrics. So if I put the light bulb instead of the yellow bulb, will this increase the creativity or decrease it? And that is something that you're able to capture at the end of the experience, right?
Yeah, that's exactly what we're doing.
Interesting. I want to touch on, you talked about the city planning application. I can think of a lot of applications for this. Roller coasters, commercial implementation for experiences in a specific magazine or a specific shop. You can basically think this in any human experience. But can you talk a bit about what are the current limitations of such models? What are we not capturing, at least in the current science and current situation?
Limitations can be depending on the situations. We are trying to eliminate limitations, of course, by giving the full flexibility to this tool that can fit anywhere, any domain, any function, or any place. It depends on how you would like to customize that solution. Because at the end, what we are giving also to our customers is a tools where they can customize their own experience. They can fully guide how our foundational model should interact in certain situations and a certain cases for certain user profiles to customize the experience based on their audience, their end users. So the limitations can be well, I'm not able to think of a limitation unless you give me a very specific context.
So I can think of, for example, our current understanding of the human mind evolves. It's we will get more knowledge about how the human think and how we modelize certain emotions going forward. So you're still able to capture that and just update your models based on the latest available science, I guess.
Our models has a feature of, let's say, self-training based on the incoming real-time interactions and requests. We don't collect these interactions at the end and then we train. Our models are evolving in real time. As much as we interact with different users, different profiles, and different contexts, our models are evolving by the time as well.
Okay. This is a fascinating domain, and you can think of also all of the other applications that others can think about this. And at some point, you're trying to understand the human brain and augment it to some level. What kind of guardrails you need to put around that in order to make sure that this is actually not being used in other applications that maybe are harmful?
All right. First of all, going back to our original principle behind this is to help the humanity, not to negatively impact, or let's say to produce a technology that negatively impacts to humans or harm them. So we have designed our since day one, since we started implementing, there is always one principle was continuing with us, which is completely anonymizing all the interactions with our system. All the data goes in our system, cannot produce, like, no way that you track back or reverse it to find out who's the actual human behind it. Whenever you interact with our system, we never ask you to provide your name, your personal details, where you live, where you what you like, what you don't like. We don't go that way. We create a unique identity for the user. That's it. It's just a unique identity just to identify his profile. Every time he interacts again with our system, we find his profile, and that's how it goes. On top of that, all the interactions are follows in a very intensive encryptions. Especially we are using homomorphic encryption, which give us ability to take advantage of that data, although it is encrypted, without decrypt that. And this is a benefit we got from AWS, where SageMaker was able to support the homomorphic, and that was very useful to us, and that was very big advantage, because we would like to continue supporting our principles by protecting the actual humans who's interacting with our system.
Well, one of the things that you mentioned before our discussion today is the liquid ethics concept that you implement and you think about when implementing these models. Can you explain a bit what's liquid ethics for Vetio?
Liquid ethics, simply, it's our ethical system is not rigid, because from one person to another, from one nation to another, the judgment is different into the situations. So you cannot always say this is right or this is wrong, because what is right here, it's wrong on the other side. That's how our dynamic liquid, or let's say dynamic ethics works. It's not fixed. It's completely iterated to fit with the current context. And it depends on how you customize that ethics to work toward. And indeed, we have our own continuous developed layers of ethics to keep our technology always ethical, always providing positive impact to the humans, rather than one day to be accused or, let's say, misused or implemented in a place that produces a negative impact. And this is very big responsibility on us, because by the time, no one knows what future brings. So from now, we have to prepare our technology to be always safe for everybody, and everyone intended to use our technology are always supposed to feel safe, because it is actually following these principles of protecting the humanity and helping the humanity.
So what are some of the things that you see probably in the future for this kind of technology? How do you think they will evolve? And maybe what are the things that you're working on for the future?
Going back to the science fictions movies that I used to watch, if you see, there is always kind of movies who brings a virtual assistant that's always there in your home, that understand you. It's not just checking your vitals and tell you what to do. You take a painkiller because it doesn't feel you are good now. No, there is another level of virtual assistant that deeply understand you. It's like another human living with you, understand you, give you the necessarily emotions. Like if you are feeling sad, that AI or that emotional powered AI feels you and start to get you, to help you getting out of that sadness. And this is where I see our future goes. And there is a lot of opportunities we can fulfill. And we can, for example, help a very critical massive incidents, like helping the pilots to always focus or to always maintain all reading all insights they have inside their aircraft to always protect the humans he's carrying or the passengers from a very massive incident that can lead to a very big loss.
This is very exciting future that you're thinking about, and I hope we'll get there at some point. I want to go back to the building part and how you actually built this from a technical perspective. You're using AWS SageMaker. You mentioned about the homomorphic encryption. Can you talk a bit about the architecture and how you actually are building these models?
Yeah, indeed. Well, AWS in general, not only SageMaker, helped us a lot to always focus on what we are doing rather than the infrastructure, the orchestration, the scalability, and everything we found in AWS was very useful from that perspective. And let's say what we have used, technology we have used SageMaker to deploy our models, to train and maintain always a healthy MLOps for our models that always available, always in scale, serving the incoming volume of interactions. Because when we talk about real-time processment, we have been able to achieve 1,200 per second, request per second, which is massive when we talk about 8 models being in real time with deep neural networks involved. We have from the other side the orchestration system was able to scale up the computation and of course the database. We rely a lot on database because we give to the customers ability to customize how they would like to the experience to go over, and that's how also AWS helped us by providing the Aurora. It was very, very good clusterization and scaling benefits or capabilities.
Any feedback? This is a massive scale from transaction per minute side. Any specific adaptation or learning that you got building that level of scale? And for somebody who's building a similar system, what do you advise them to do?
All right. First of all, you keep an eye on your cost, because cost on high scale can go out of control. And how you can do that, first of all, before you jump in, taking advantage of AWS services, go and read the documentation, read the ecosystem, because AWS provided a very extensive or customizable components and services that fit every situation, but it depends how you use it. So you have to be aware what you are using, and then you will take fully advantage of AWS, where you will be in a controlled cost, serving your goal of volume, let's say.
Yeah.
But yeah, and from another perspective, of course, reading the documentation ecosystem will give you another dimension of how you configure these components and these services to serve exactly what you would like to serve.
So the cost per transaction, when you are able to control that and make it as low as possible, then when you scale, you see the benefits are also scaling. You mentioned Aurora serverless. Is it serverless first?
No, actually, we have gone beyond that because our volume wasn't good with the serverless. We go with the provisioned instances. Mm-hmm. And yeah, there's a trick there. We found that depends on your type of usage, you have to configure the service. For example, if you have very high I/O usage and the high volume, then consider to use I/O optimized instances rather than the standard instances. But of course, you have to know the limitations of our optimized I/O optimized instances comparing to the standard instances. At the end, you will choose what is fit to you, but don't just use randomly. At the end, you will not take fully advantage of AWS, which is very, very useful tools.
Exactly. Outside of this scaling problem that you're handling, you've been building on AWS for some time now. What is your advice to startup public sector organizations just starting to work on AWS to build AI models, to build new platforms? What's your feedback on that? And I'm looking for the good, the bad, and the ugly. what are some of the things that really helped you accelerate things, and maybe some of the things that you wish you knew before.
All right, starting up with AWS, I think it's very, very beneficial because you don't need to always reinvent the wheel. It's always there. Some service or some use case has been applied and published on the blogs of AWS that gives you a hint how to achieve that without experiment, without going into R&D phase, which R&D always expensive in time and money. So these use cases were very useful. Whenever we face a very big challenge, we used to go over these use cases, see how people achieve that or resolve that using AWS technology. And it was very useful for our growth because when we talk about startups, they are a small group of people and there is no team member that's specialized on every side of their development. And that's another benefit we took from AWS.
Perfect. Any final thoughts you want to share about the work you're doing on emotional AI? And we've been talking basically on the effective compute that you're using and also about the affective compute that you're building. Any final thoughts on this general field in general?
All right, maybe it's a highlighting that this kind of technology will one day help the AI companies to build ethical and customizable, or let's say personalized technology. This kind of technology, what we are building, the foundational model, will give them an extra layer to their technology. If they are an AI company building just an AI agents or any AI based on large language models, we can add our EDA in between to personalize and to mind about the state of the human behind that interactions or behind that screens. That's what I would like to.
Thank you very much. This was a very insightful discussion, and I'm looking forward to see all of the applications coming forward from Virtue. You're part of creating a best future and a better future for us, and hopefully we'll see all of these applications moving forward all around us. Thank you very much, Moayad.
Thank you. It's a pleasure.
Thank you. That brings us to the end of today's episode of AWS for AI, where we went beyond effective computing to talk about effective computing. You can find links in our show notes if you're interested in learning more about emotional AI and the work Virtue teams are doing. Don't forget to like, comment, and subscribe to AWS for AI on your favorite podcast platform. And as always, until next time, this is Hamza Mimi thanking you for your listening. Keep exploring, keep innovating, and we will catch you on our next episode.